Welcome to another episode of Terry's Notes, and today we are going to be looking at linear programming. Alright, one of the things that you need to understand before you can do linear programming is to be able to sketch the solution to a linear inequality on a graph. Right? I prepared a video on this already, so you should take a look at that video before you start linear programming. So let's start with our first example here, and this is from the June 2012 paper, question 9. So with linear programming, we can use this technique to determine how to maximize profit for a particular organization, or how do we reduce cost. All right. So in this example, a florist makes bouquets of flowers, each consisting of X roses and Y orchids, right? For each bouquet, she applies the following constraints. Now, usually in a linear programming question, we have two variables that we're going to use, which could represent anything. In this case, X represents roses and Y represent orchids, right? And they give you some constraints here. So they said that the number of orchids must be at least half the number of roses. Now, in order to write the inequality, you just need to look at the wording of what is being said. So orchids is represented by Y, and roses are represented by the letter X, right? So the commander said orchids must be at least half of the number of roses. So in order to write that as an inequality, it will be Y. Now they said at least half, which means it should be greater than or equal to a half X, right? So at least half means half or more, right? So that's why I didn't write Y is less than or equal to half X. And the next inequality is there must be at least 2 roses. What does that mean? Now, roses are represented by the letter X, right? So there must be at least 2 roses means that X must be greater than or equal to 2. That is the second inequality, right? And then the last one is that there must be no more than 12 flowers. So when I say no more than 12 flowers in a bouquet, now remember the bouquet is made up of roses and orchids. So therefore, if we add the number of roses plus the number of orchids, we should have no more than 12. So therefore, the inequality should be less than or equal to 12, right? So what they're saying is that if I add the number of roses and the number of orchids, I should not go beyond 12. So that is why I'm using less than or equal to 12. So our inequalities are therefore Y is greater than or equal to half X. That's the first one. The second inequality is X is greater than or equal to 2. And the last inequality is X plus Y is less than or equal to 12. So these are the inequalities for part 1. Right? You just have to pay attention to the wording and be very careful. Alright, so set on the answer sheet provided, the shady region of the graph, which represents the solution set for the inequalities we've been provided with. Alright, so the first inequality is Y is greater than or equal to half X. Okay? So first thing we need to do is to draw the line Y is equal to a half X. And like I said, in order to draw a straight line, all you need are 2 points. So let's say when X is equal to 0, Y is equal to half of 0, which is equal to 0. So 1 point on the line should be 0, 0. Right? So that could be this point, that is this point here. Then we can choose another point when x is equal to, let's say, 6. Then y would be equal to a half of 6, which is equal to 3. So therefore this point will be 6, 3. So therefore we plot that, if we plot that point, that will be here. And we draw our straight line through this point here, and this is y is equal to a half x. Now, if we remember what the inequality was y is greater than or equal to a half x. Okay? So the inequality is y is greater than or equal to a half x. Now, in order to determine which side of this line we should shade, we need to choose a test point. So let's choose, what if I choose this point here? Right, I'm going to choose this point here. This point is 4, 1. You can choose any point, right? So let's substitute it into the equation and see if the statement is true. So y is 1 is greater than or equal to a half by x, which is 4. So therefore 1 is greater than or equal to 2. This statement, 1 is greater than 2, that is false. Right? So we know we can't shade anything on this side. Can't shade anything here. Let's choose another point. Let's say 2, 4. Alright, this is the point 2, 4. Y is greater than or equal to a half x. Y is 4 is greater than or equal to a half by 2. Therefore 4 is greater than or equal to 1. So this is true. So therefore the point 2, 4 satisfies the inequality, which means that we need to shade this region here. Right? So this region represents y is greater than or equal to a half x. Okay, hope you'll catch that. Now, what was the second inequality? The second inequality is x is greater than or equal to 2. So we have to draw the line. So the inequality is x is greater than or equal to 2. So therefore we must draw the line x is equal to 2. Whenever you have to draw a line x is equal to a constant, it's just a vertical line parallel to the y-axis. So this is the y-axis, this is the x-axis, and this is the line x is equal to 2. Now x greater than or equal to 2 is pretty straightforward to shade. That is this region here. Right? And remember this line here, the blue line, that was supposed to be y equal to a half x, and the inequality was y is greater than or equal to a half x, and the shaded region for that was this. Right? So we have a third inequality now, and that third inequality was x plus y is less than or equal to 12. So it's x plus y is less than or equal to 12. So therefore we need to draw the line x plus y is equal to 12. Alright? So in order to draw this straight line, we need to choose 2 points. So let's say we choose a point, let's say when x equal to 3, we end up with 3 plus y is equal to 12. Therefore y is equal to 12 minus 3. So therefore y is equal to 9. So therefore this point is 3, 9. So 3, 9 is this point here. Alright, then we need to choose another point. So let's say when x is equal to, let's say 9, we end up with 9 plus y is equal to 12. y is equal to 12 minus 9, so y is equal to 3. So therefore this point is 9, 3. 9, 3 is this point here. So therefore this line here represents x plus y is equal to 12, right? And remember, this is y equal to a half x, and this is x is equal to 2. All right, now so far we've shaded the region for the inequality y is greater than or equal to half x. Was it greater than? Yeah, sorry. And we've also shaded the inequality x is greater than or equal to 2. Now we have to shade the inequality x plus y is less than or equal to 12. So which region is that? So we are looking at this line here, right? So we need to choose a test point. Now I like to choose 0, 0 as a test point. So let's substitute 0, 0 into the equation. So 0 plus 0 is less than or equal to 12. So 0 is less than or equal to 12. So this is true, right? So before I do anything else, I know chances are I have to shade this region here, right? Let me choose another point here. Let's say 6, 9. Let's say this point here, right? So 6 plus 9 is less than or equal to 12. 9 and 6 is 15. Is less than or equal to 12. That statement is false. Right, so therefore I'm not shading anything on this side of my line. Right, so again I'm going to stay in this region here. Right, so the thing is, we have 3 inequalities and each one of them is represented by a different region. So when we did x was greater than or equal to 2, we shaded everything going this way. Right. When we shaded y is greater than or equal to half x, we shaded everything above this line, the blue line here. Right? That is this region here. And now we are shading the x plus y is less than or equal to 12 is everything this way. Now this is looking a little scrappy right now. I'll give you a better drawing. So the region that satisfies all 3 inequalities would be this here, right? That is this triangle here. Right? And it is that region is represented by this triangle here with these vertices that I'm shading here. And these vertices are important because chances are they're going to ask us something about them. So this point here is 2, 1. This point here is 8, 4. So this is 8, 4. And this one here is 2, 10. Alright? So the second part of the question where it said to shade the region of the graph which represents the solution sets to all the inequalities. That is, use a different color here. So that is this region here. Make sure you catch that. That is this green one that I'm shading here. Alright, this is our solution set for all 3 inequalities. Now, I have a better diagram here. So this region here represents our solution set, right? Now, what else did the question ask us? They said, state the coordinates of the points which represent the vertices of the regions showing the solution set. So we just did that. The coordinates are 2, 10, 8, 4, and 2, 1, right? Then the florist sells a bouquet of flowers to make a profit of $3 on each rose and $4 on each orchid, determining maximum possible profit on the sale of a bouquet. So make sure, so right, so to make $3, let's go here. So they said the profit that they make on, okay, hold on, let me just, okay, so let me write down the coordinates here. So the coordinates are 2, 1 and 2, 10. So we have 2, 1, 2, 10. Sorry, it's a 10. And 8, 4. 8, 4. Now they came and in the question they said the florist sells a bouquet of flowers to make a profit of $3 and a rose. Sorry, the profit is $3 on each rose and $4 on each orchid, right? So what you need to do is to write an equation for the profit. So the profit will be 3 multiplied by each rose. A rose is represented by x, so it's 3x plus 4y. 3x plus 4y. So that is the profit equation, right? Right, because they told me they will make $3 on each rose and $4 on each orchid. And these are the vertices of the region that satisfy all inequalities. What you need to do, they want the maximum profit. You have to take each one of these points and work out the profit. So let's choose the first point, which is 2, 1. So it'll be 3 multiplied by 2 plus 4 by 1, which will give me 6 plus 4, which is $10. Right? So that's using the point 2, 1. Now we're going to use the point 2, 10. So this will be 3 by 2 plus 4 by 10, which is equal to 3 to the 6 and 40, which is 46. And the last one will be 8, 4. So we're going to use the point 8, 4. And the profit will be 3 multiplied by 8 plus 4 by 4, which is equal to 3 8s are 24 plus 16, which will give me $40. So which one gives me the maximum profit? Obviously we're looking for the one that is $46. So therefore the solution should be, we should put x is equal to 2, which represents roses, and y is equal to 10, which represents orchids. Right? So in the question when they said determine the maximum possible profit on the sale, right? The maximum profit is simply the $46. That's what we have here. And if they ask us, they didn't ask us that in the question, but if they want to know what quantities we should use, the quantities that we should use should be 2 roses and 10 orchids. All right. So for some students, linear programming can be very confusing, but just review this question again. You will get it. Don't worry. I will do a next example. So this one is from the June 2009 paper, question 10. So you have the owner of a shop which wishes to buy X guitars and Y violins, right? To satisfy the demands of his customers. The number of violins must be less than or equal to the number of guitars. So write an inequality to represent this. So the number of violins is Y, must be less than or equal to the number of guitars. So y must be less than or equal to the number of guitars, which is represented by x. So that inequality is pretty straightforward. It's just a matter of converting a worded statement into an equation. Now they said the cost of one guitar is $50 and the cost of one violin is $300, and he has $4,500 to spend on the purchase of these instruments. So if he has to buy X guitars, right, then the cost for X guitars will be 150 multiplied by X, because $150, they told us that is the price of one guitar. The price of one violin is 300, so it's 150X plus 300Y, and they told us that he only has this amount, 4,500, to spend, which means that the total cost should be less than or equal to $4,500. Okay, so this is in terms of money. He has 4,500 to spend, and if we know that 150 is the cost of one guitar, then it will be 150X, and the cost of one violin is 300, so it's 300Y. All right. And then the last inequality, to get a good bargain, the owner of the shop must buy at least 5 violins. Violins is represented by Y, so therefore he must buy at least. At least means Y is greater than or equal to 5 violins. Right? So now we need to convert that now into, give me a second. Right. So part B now, they're gonna obviously ask us to draw this information. So they said using a scale of 2 centimeters on the horizontal axis to represent 5 guitars and 2 centimeters on the vertical axis to represent 5 violins, draw the graphs of the lines associated with the 3 inequalities. Alright, so the first inequality was Y is less than or equal to X. So the first inequality is Y is less than or equal to X. So therefore we need to plot the line Y is equal to X. So in order to draw the line Y equal to X, we need 2 points. So we can choose, let's say X equals 0. When X equal to 0, Y is equal to 0. So therefore the first point we can use is 0, 0. That is here. We can say when X is equal to 4, Y is equal to 4 as well. So therefore the point is 4, 4. So that is this point here. So we just draw a straight line through 0, 0 and 4, 4, and we get the line Y is equal to X. Now the inequality is Y is less than or equal to X. So we use our test point scenario. Let's say we choose the point 2, 1. I'm going to choose this point here. Right? And the inequality is Y is less than or equal to X. So this is the point 2, 1, right? So therefore 1 is less than or equal to 2. Is that statement true? It is true. Right? So without even doing anything further, I know I'm going to have to shade this region here. Right? If I choose a point that is, let's say 1, 4, this one here, this is 1, 4, and Y is less than or equal to X, so therefore 4 is less than or equal to 1. That is a false statement. That is not true. So therefore this is the region here for Y is less than or equal to X. Now what is the other inequality? Now the other inequality was 150X plus 300Y, so I can remember that. So it's 150X plus 300Y is less than or equal to 4,500. Less than or equal to 4,500. Right? So we know that we have to draw the line 150X plus 300Y is equal to 4,500. Right? Now we need 2 points. So let's say when X equals 6. When X equals 6, we end up with 150 by 6 plus 300Y is equal to 4,500. Now I'm going to do a little shortcut here. Y is equal to 4,500 minus 150 by 6 over 300. So therefore y is equal to, and I'll use a calculator to work this out, so 4500 minus brackets 150 times 6 divided by 300, and we end up with 12. Right, so this point is 612, and that will be where's 612? 612 is this point here. Right, so this is 612, and let's say we choose another point. Let's say when x is 30. Right, when x equals 30, we substitute it and we'll end up with y is equal to 0. Right, I'm not going to work it out here, you all can try, and that point is represented by this here. So this line here, this straight line here, is represented by 150x plus 300y is equal to 4500. Right, and again we need to shade the correct region. So the inequality is this. So I'm going to use the point 0, 0. So let's see, 150x plus 300y is less than or equal to 4500. So if I use the point 0, 0, we'll end up with 150 by 0 plus 300 by 0 is less than or equal to 4500. So therefore 0 is less than or equal to 4500. So this statement is true. So therefore, obviously the region that we're looking at is everything below this line. Right? And our last inequality was y is greater than or equal to 5, which is pretty easy. So this is the line y, so it's y is greater than or equal to 5, and this is the line y is equal to 5. So therefore y greater than or equal to 5 is represented by this region here. Right, now combining everything that we've shaded, we will end up with, so this is y equal to 5, this is y is equal to x, y is equal to x, and that region was, we had gotten everything on this side, and then this was the other equation, which was 150x plus 300y. So this one was 150x plus 300y is equal to 4500. Right, and that region was represented by everything below here. So the region that actually satisfies all the inequalities is represented by this fellow here, this guy. Right, chances are we may have to use the vertices of this triangle. So let me just write it on one time. This is this one is 10, 10. This one is 25, 25, and this one here is 5, 5, 5, 5. Right? That piece of information might be important. Alright, so this is just another graphic showing the region we are talking about. So the combined region is really represented by this guy here, right? What is the last part? So the owner of the shop sells instruments to make a profit of $60 on each guitar and $100 on each violin. So which one is the guitar? Don't mix them up. So the guitar is represented by X, right? So the guitar is X and the violin is Y. Right? This that express the total profit in terms of X and Y. So the profit will be equal to 60X plus 100Y. Right? They gave us this information. They gave us the 100 and the 60. and they want the maximum profit. Now, in order to get the maximum profit, we're going to use the coordinates of the vertices to figure that out. So let's start with 5, 5 as the first one. So let me just write them down. So it's 5, 5, first one. Second one is 10, 10. 10, 10. And the last one is 25. Alright, so what we're going to do, we're going to work out the profit for each one and determine what the maximum profit is. So profit here is 60 by 5 plus 100 by 5, and this will be, let's work that out, right? 60 multiplied by 5, it's 300 plus 500, that gives me $800 profit. So this is $800. The next one will be 60 multiplied by 10 plus 100 by 10, which will give me, that is 600 plus 1000, that is 1600. And then the last one is 60 by x, which is 20 plus 100 by 5, which will give me 60 by 20 is 1200 plus 500, which is 1700. Alright, so our maximum profit is therefore 1700. Right? So the answer for this part is 1700. And if they were to ask you, well, what is the quantities that we need to sell? We need to sell 20 of the guitars and 5 violins. Alright, so this is a pretty difficult topic for some students, so I would suggest that you go through this video several times before you understand how to do linear programming. Right, I will try to do some more examples, right? But you have to practice, practice, practice.